Today I will be introducing our experiment on the correlation of density and buoyancy of Lego blocks. The experiment question we have is, how does the density of the block affect the speed at which the block surfaces from the bottom up in a tub of H2O, water? Horrible joke. Okay, these are the keywords and definition you can see here. And yeah. Buoyancy is the force that opposes gravity when an object is placed in a fluid. Studs are the connection points on Lego blocks that allow two or more Lego blocks to link together. Density describes the amount of mass packed into a certain amount of volume, usually written as grams per centimeter cubed or kilograms per meter cubed. I couldn't do the superscript to signify the power. Lego is just interlocking plastic brick toys. Our hypothesis is that we predict that the density of the block has a direct correlation with the speed at which the Lego block surfaces. We believe so as the density of a block has positive correlation with buoyancy. So the lower the density, the stronger the buoyant force. As a result of a stronger buoyant force, the object surfaces faster. The procedures are listed here, and you can read them yourself. And yeah. Here are the table of data we have, and the red text stand for anomalies that we have recorded. And in both cases of the anomalies, the block have sunk, despite various trials. Also, the block that have sunk are given a time of 10 seconds. And these are the charts. On the left, we have the chart which presents the density of the various Lego types versus the Lego type. And on the right, we have the density of these various Lego types versus the time they took to surface. You can see that the 1x6 block, which had around the density of 0.6 grams per centimeter cubed, took the longest time to surface. And the conclusion is that our hypothesis is mostly correct. The trend line on the chart on the previous slide had a positive slope indicating a positive correlation. I say mostly because there were a few anomalies that heavily affected the Lego type's average. For example, the sinking orange 1x2 block raised the average from what would be 0.99 to 1.75. Our experiment does have problems with it. Even though density does affect buoyancy, we did not take water resistance into account. The 1x6 block had similar densities and mass with the 2x3 block, but they had a significant difference in their time. The 1x6 block had more trouble pushing water above it to float, causing it to go in chaotic patterns like it was experiencing turbulence. Next time we would probably bring objects with similar volume but with different densities.